This is a brief explanation of what Reason does. It is a tool that helps your mind detect every meaningful relationship in groups, sequences, or other connections in data about your work in almost any field. You will enter data and then model it like manipulating a lump of moist clay to synchronize the monitor displays with your thinking. The controls for doing that have been designed to help you intuitively learn Reason by opening the sample dataset and experimenting with ample use of the tooltips. But first, an analogy illustrating why Reason works. The next time you enter or leave a commercial aircraft, try to look toward the front of the plane, past the pilot's seats. You will see on the instrument panel something like this. Called a glass cockpit, it simultaneously displays on a monitor data from several sources that were once displayed on many separate instruments. That helps faster integration in the pilot's mind of not only what is seen, but the pilot's knowledge, experience, and skills. Reason does something like that by letting you simultaneously see as much data as possible about the things you are examining. And the data you examine using Reason are truly your data, not data imported from somewhere else, data you have to assume are both adequate in number and fully valid. Instead, you create text data items for each of the things, objects, events, names, anything that you want in the collection you are going to examine for relationships. Later, you can easily and quickly add items and delete those that appear useless. You will start by building two simple lists, one for the parameters, characteristics you want to use, and one for the values you expect them to have. While you are later examining the several choices of data displays, you can easily and quickly make changes in parameters and their values wherever you see them. A data specification, often abbreviated spec, is used to create a data item to be saved in Reason. You select the parameters and their values and then, or any time later, enter up to a page of text in the description field. And later, after detecting important relationships with other items, you can open their specs by clicking their item IDs that you entered in this links field. Other spec details will be covered in a moment. You can build as many different sets of data as you wish. The number of items in a data set is limited by the number you can effectively study when they are displayed and in the height of the adjustable data table, which is one of the several displays in which you view the data. You select data items for examination with a query, a dialog box like this. Imagine you are an archaeologist who wants to assemble dozens of randomly numbered shards recovered from an ancient site. You built this query by naming it, then choosing the parameters. Their values for the recovery initially read all, but for the depth parameter you clicked the More Information square button on the right. That opened a list of math operations, and after you selected Between, you entered the values you want. So Reason will now process only data about shards found between 12 and 24 inches from the surface. There are three ways to view the results of a query. This is a Reason data table. The list shows the parameters first, then the item IDs. Each ID is analogous to a phone number in a phone book. The name and address are parameter values that lead you to the phone number you want. It's also like an airport monitor with destination and time leading you to the right gate. The other window lists queries which, when you saw an important table while permuting, you decided to save by clicking Q to return to the query screen and there clicking Save. This window is displayed along with the table and several other times. Clicking an empty square in the first column marks that item for deletion from the query, not from the dataset. Next to the column of squares is a column with yes or no, indicating whether you have decided an item is related to others in the dataset. Next are columns of parameter values that lead you to the item ID. If you rearrange the 5 parameter columns on this table, the left to right sorting will cause the parameter values to move around, probably the item IDs also. But there are 120 ways to arrange those 5 parameter columns. That is laborious, and ideas generated by early permutations will be forgotten after you have examined more. And think of the 720 permutations of 6 parameters, or 7 parameters with 5,040 permutations. But if you don't examine every permutation, you may miss something very important. That led to our patent for automated permutation, which greatly simplifies examination of every possible arrangement of the columns and parameter values. Still, examining large numbers of permutations can be wearing. A recent patent of ours fixes that. Look again at the table. If you click the name of a parameter, that column will be excluded from sorting, but it will remain in view. In this screenshot, for example, the number of permutations is reduced from 120 to only 24. You probably know more about the items than the parameter values you see here, especially if you wrote in the description field of the specs. So when you click an item ID on the table, its spec appears in a separate window. You can see the description, the specs of any links, and a note if there is one. Under it, functionally, not now visible, are specs for all the items on the table. At the top of this virtual stack of specs are controls for browsing through the stack, automatically at the speed you set or manually. You can enter text and/or colors in any of the marker fields at the bottom of the spec page to help later retrieval. Those functions are also covered by our patents. Browsing back and forth through a stack alone can, in some cases, be a very effective analytic tool. Displaying just the stack is the second choice after building a query. You may like to begin by displaying the table and stack simultaneously, which is the third choice at the bottom of the query window. In all views, you can drag and drop the windows to the location your working memory tells you is best for you. That term, working memory, is not one we use every day, but it is the key to running this software. Working memory relates, according to cognitive science, to reasoning, problem-solving, analogies, formulating goals, and decision-making. And although you consciously control it, unconscious control can also occur. That often happens while running Reason when, without a conscious decision to do so, you take an action or an unexpected thought pops into your consciousness. Reason is new, the first software to use many, but not all, of the patented inventions in our portfolio. And it's a new type of software that fits no existing category. As you operate Reason, your mind, not a set of software algorithms someone else wrote, is controlling the data processing. You will draw conclusions that are uniquely yours. Expect surprises.